The graph at the top of the page shows a curve that behaves differently in different regions. So we can see that we have to be careful if we fall into the third case. For those times when we do fall into the case, we'll have to resort to other methods of classifying the critical point. This is usually done with the first derivative test, but if you have time, you can go back and take a look at the critical points from the first example and use the second derivative and test on them if possible, since it will really help classify these critical points based on the concavity of the function. And in this topic, guys, the main focus here is how to classify critical points of a function using the second derivative test. And the example in the image uses a polynomial function. H of x is equals to 3x raised to the power of 5 minus 5x cubed plus 3. So step 1, guys, we need to understand the problem. So the goal is to classify the critical points of the function h of x. Critical points are values of x where the first derivative is 0 or undefined. Once we identify these points, we use the second derivative to determine if they represent relative maxima, minima, or are inclusive. We have step 2, finding the second derivative. The function given is h of s equals to 3x raised to the power of 5 minus 5x cubed plus 3. So the first thing that we're going to do is to find the second derivative, which is needed for the second derivative test. The image provides the second derivative, which is 60x cubed minus 30x, and this was obtained by differentiating the first derivative twice. Now we use this to classify the critical points. Step 3, identifying critical points. So critical points are where the first derivative is 0 or undefined. These critical points were found in a previous example, not shown in the image, and they are x is equals to -1, x equals to 0, and x equals to +1. The first derivative was 0 at these points, making them candidates for classification using the second derivative test. And we have step 4, the last step, applying the second derivative test. So to apply the second derivative test, we evaluate the second derivative at each critical point. At x equals to -1, since the function is concave down, at x equals to -1, indicating a relative maximum at this point. There is a relative maximum because the second derivative is negative. At x equals to 0, the test is inconclusive at this point. This means the second derivative test doesn't provide enough information to classify this point, and we might need another method like the first derivative test. And at x equals to +1, the function is concave up at x equals to 1, indicating a relative minimum at this point. There is a relative minimum because the second derivative is positive. So this is how to apply the second derivative test to classify the critical points of a function, determining whether they correspond to maxima, minima, or if more information is required. So that's all for today, everyone. I hope you understand and learned something from me. Thank you so much.